The verification phase is supposed to reduce uncertainty. Raw Webb data moves through independent reconstruction teams next. Different correction methods. Different processing assumptions. Separate image pipelines built specifically to isolate instrument failure. The results should begin separating. Instead, they converge. Color balance shifts between reconstructions. Noise patterns change shape. Some galaxies sharpen harder than others. The images visibly disagree with each other. But the directional drift remains identical across every version. One analyst freezes the comparison screen halfway through the overlay cycle. Nobody speaks for several seconds. Because independent correction systems are no longer weakening the contradiction. They are reproducing it. Calibration screens stop looking trustworthy first. Another Webb survey reaches deeper into cosmic history, farther back than Earth even existed, and the comparison models begin separating again. Bright structures emerge across black space in long connected lanes. Not random clusters, not partial formation. The same faint geometry keeps returning beneath the image. Ancient galaxy structures begin lining up into something closer to a grid. At first, the simulations start bending the physics to fit the pattern. More dark matter, different expansion behavior, earlier gravitational shaping. Each revision fixes one section of the map, then destabilizes another. And the contradiction gets worse. If some buried process organized the early universe, the models should become easier to predict. Instead, the stronger explanations begin damaging the model itself. One corrected region immediately throws another out of alignment. Large-scale timelines stop aligning cleanly. Webb keeps producing cleaner organization than the system can comfortably absorb. One assumption underneath modern cosmology has stayed mostly untouched. The universe forms gradually from irregular beginnings. But the deeper Webb maps, the less gradual the structure appears. That is the failure moment. The clearer Webb makes the map, the more unfinished the explanation begins to look. Observation itself becomes the pressure point. Webb mapping a universe that already looks partially organized stops feeling isolated. The map keeps organizing itself the wrong way, and the universe stops looking naturally random at all. Separate Webb sectors begin failing the same way. One deep field drifts slightly against its alignment grid. Then another region, captured months later, develops the same directional separation. Different galaxies, different coordinates, millions of light years apart, yet the overlays begin leaning across the screen at nearly identical angles anyway. Separate directional overlays begin locking into the same orientation. Calibration review usually moves fast. New filters, new corrections, new reference points sliding over the image. This time the filters stop cycling halfway through the comparison. Analysts stop talking as the second region finishes rendering beside the first. The angle matches almost perfectly. If isolated corruption damaged one observation, unrelated regions should not fail the same way. But the movement keeps repeating across separate, deep fields, and the same motion pattern emerges from unrelated observations. Now the same motion is appearing in regions that were never supposed to connect. Now the search turns back toward the telescope itself. External interference, environmental distortion, a hidden source affecting multiple observations at once without appearing inside the frame. But the contradiction keeps widening. Separate datasets begin behaving identically. The comparison models stop behaving like isolated errors. Humans can tolerate one damaged result. Confidence breaks much faster when independent systems fail the same way twice. and the background keeps changing before the explanation catches up. Engineers finally get a version of the explanation that looks stable. Thermal distortion maps spread across the monitors first. Tiny fluctuations inside the telescope. Sensor expansion from temperature shifts. Minute alignment drift while James Webb stabilizes infrared observations near L2. The corrections visibly improve the image almost immediately. Noise begins fading from the deep fields. Old comparison frames sharpen. Smearing disappears along the edges of distant galaxies. Background interference weakens. Calibration markers begin locking cleanly into place again. For a moment, the contradiction appears smaller simply because the images become clearer. Then the recalibrated overlays finish rendering. The noise fades. The galaxy alignment does not. Nobody reacts right away because the recalibration did exactly what it was supposed to do. The image quality improved exactly the way the model predicted. But the directional movement survives inside the cleaned data almost perfectly unchanged. That is when the explanation starts collapsing. If thermal distortion caused the movement, the recalibration should have erased it too. Instead, only the noise disappears. The drift remains inside the corrected image like it was part of the original structure. The correction process accidentally validates the contradiction. Sharper images feel safer, more controlled, more understandable, but calibration changes image quality without changing anomaly behavior, and the confidence attached to the explanation begins weakening immediately. The strongest explanation so far survives only by failing. The verification phase is supposed to calm everything down. Raw Webb data moves through separate reconstruction teams next. Different correction methods. Different processing assumptions. Independent image pipelines built to catch exactly this kind of hidden instrument failure. One group finishes first, then another, and the same movement keeps returning. Multiple corrected deep fields keep collapsing into the same misalignment. At first, the reconstructions look different enough to feel reassuring. Color balance shifts slightly between versions. Background noise changes shape. Some galaxies sharpen more aggressively than others. The reconstructions visibly diverge from each other. But the directional drift does not. Every corrected image preserves the same angular separation across the same regions of space. The displacement survives each reconstruction pass like it already exists underneath the processing itself. That is when the verification process starts turning against the explanation. If the telescope caused the anomaly, the corrections should start separating. Instead, they converge. Different reconstruction methods producing identical movement patterns across enormous cosmic distances. Then the telescope failure theories begin collapsing publicly. James Webb reproducing the same movement repeatedly removes the safest explanation almost immediately. Verification systems begin reinforcing the contradiction instead of suppressing it. One silent pause follows the final comparison screen. Nobody opens another correction pass. The data becomes harder to dismiss exactly when the explanation stops holding together. And for the first time, the instability no longer appears trapped inside the telescope at all. Another deep field arrives looking perfectly stable. No flickering distortion, no corrupted exposure. The stars remain sharp. Ancient galaxies hold their shape cleanly against the darkness, while James Webb, watching deep space change between observations, continues the same routine process that worked before the anomaly ever appeared. Then the older coordinate grid fades back onto the screen. Ancient galaxies begin drifting against coordinates that previously stayed fixed. The movement is small at first. Entire structures larger than galaxy clusters sliding slightly sideways against reference positions that previously matched without issue. Not chaotic motion, not random instability. The geometry changes slowly enough to look almost believable. That slow consistency is what makes the movement harder to dismiss. One detail becomes difficult to ignore. The telescope itself still appears to function normally, and the safest explanation starts collapsing again. If gravity causes the distortion, the source should appear before the surrounding space begins shifting, but the distortions arrive first. The directional shifts emerge across space before any detectable object or gravitational structure exists to explain them. That is when the comparison system stops making physical sense. The coordinate system stops holding still long enough to trust between observations. Stable observation systems continue functioning while interpretive certainty disappears underneath them. The universe appears internally consistent while remaining externally unexplained. Astronomy depends on stable reference points, on repeated observation, on coordinates remaining fixed long enough to compare. But the evidence now suggests something far worse than telescope instability. Space itself appears to react before humans understand what changed.